We'll next look at Chapter 11, which is the second chapter on the binomial option pricing model and its properties. And we'll split this chapter into 6 modules. First module is going to discuss the question of early exercise in a little more detail. We saw in the prior chapter how to evaluate an American option and how to reflect early exercise in our calculations. And here we're going to just look a little more carefully at early exercise. So options may be rationally exercised prior to expiration, and the logical and the rational motivation is that we see, and we've actually observed this in some of our examples, we would see that the exercise value of the option exceeds the value it has in the future. When we do an expected present value of future option values using the backward substitution methodology, that tells us the value of the option reflecting all future opportunities for exercise. If the value today by exercising exceeds that, then it's totally rational to exercise, because what we're saying is that the value of exercising today exceeds the value I ascribe to the opportunity of all future exercises. And when the option holder exercises, what happens? Well, if it's a call, let's assume that it is, the option holder receives a stock, and so would have the benefit of the stock, any appreciation that occurs on that stock, but also dividends from that stock. On the other hand, the option holder has to pay a strike. Again, it's a call. You buy a stock, you have to pay a strike price. Therefore, there's an opportunity cost. So early exercise has a benefit. You get the stock and any dividends from the stock, but it also has a cost, that being the interest cost associated with lost earnings on the K dollars that you use to exercise. By exercising early, you also lose insurance implicit in the call. And what is that insurance? Well, it's the possibility that the stock price will be less than the strike at expiration. So, for example, if it is less at expiration, you would not have bought it if you waited, whereas if you bought it early, you now have a stock that's depreciated and you, in effect, are paid too much. So you can think of it as insurance. So now if the volatility is 0, then the insurance has no value because the stock price is not going to change from where it is today. So it's therefore optimal to defer exercise or exercise, depending on the relationship between RK, the interest that we lose by exercising early, and delta S, the dividends we earn by exercising early. So we'll defer exercise if RK is bigger than delta S. If we can earn more money by holding K dollars than we can by exercising and earning dividends, then with no volatility of stock, the logical thing would be to defer exercise. It's optimal to exercise, however, just reversing the inequality when S is bigger than RK over delta. It's just reversing the inequality and solving for S. So in a special case when R is equal to delta and there's no volatility, then basically you should exercise immediately as soon as the option goes into the money. These are interesting observations, but of course in the real world, stock always has price volatility. And when volatility is positive, the insurance has value. If you exercise early, there is certainly a chance that the value of the stock will drop below its exercise value before expiry, and you would be sorry that you exercised early. So the insurance has positive value